Today's topic is propagation of sound. Now, when sound is produced, the place where the sound is produced is called as source. Suppose this is a tuning fork, it is producing sound. On last term, we have studied that a tuning fork produces a specific frequency of sound which is indicated over here, that may be say 512 or any other number. Whatever number is written, that means that the frequency means number of vibrations made by this tuning fork in 1 second. Now propagation. How does the sound from here of tuning fork reaches your ear? This is your ear, suppose. So how does the sound from this tuning fork reaches your ear? That is called propagation of sound. You can hear the voice of your friend even though you may not see him or her. This happens because sound travels from one place to another in form of waves. Sound travels in form of waves. Sound propagates in form of waves. Now, what is a wave? You see, there's a source and there's an observer. In between the source and the observer, this is the source and this is the observer. You may also call listener, the source and the listener. So there can be a source and there can be a listener. The source produces vibrations. When an object vibrates, these vibrations make the particles or the molecules of the medium also to vibrate, which in turn transfers the vibrations to the neighboring molecules or particles, and the process continues. This is how the sound from one place goes to the other. Now, in between the source and the observer, there is a air, that is the medium, molecules of air. Now, when this vibrates, it gives the vibration to the nearby molecule. This molecule gives it to the next molecule, and so on. It reaches the observer. When sound is produced from the source, due to the vibrations, the vibration is transferred from here to the next molecule, that is the nearby molecule, and the nearby molecule transfers it to the next molecule, and this transfers it to the next molecule, and so the sound reaches the observer. So sound is produced from here due to vibrations, and these vibrations, they are transferred from here to the observer. Now the waves, because of which the sound from the source reaches the observer, these are called as longitudinal waves. Longitudinal waves. There is one more wave that is called as transverse wave. So the waves are longitudinal waves and transverse wave. Second type of wave is transverse wave. In longitudinal wave, the particles vibrate in the same, suppose this is a particle, it vibrates in the direction of the wave propagation. The wave is going in this direction, the particle is vibrating in this direction. So that is longitudinal wave. This is longitudinal waves. And in transverse wave, when the wave is going in this direction, the particle is vibrating up and down, perpendicular to the direction of the wave propagation. So longitudinal waves, they are generally in form of crust. These are called as crust. When the waves come closer, that is called as crust. And when the waves move away, that's called trough. So longitudinal waves, they move with the help of crust and trough. That is, sound is produced here, the waves compressed, then relax, then compress, then relax. So the particle is vibrating in this way. That is longitudinal waves. These are longitudinal waves. And in transverse waves, suppose there's a pond of water and you throw a stone in it, then you see the ripples are produced. The disturbance is, this place is the disturbance, but these circular ripples are produced. Now this is here, the waves is produced, the disturbance is here, the wave is produced, and the wave moves like this way, the ripples are like this way, and they are propagating like this way. This is called as transverse wave. Transverse wave. In transverse wave, the particle moves, every particle moves perpendicular to the direction of the wave propagation. Wave is going here in this direction, and the particle is vibrating in this direction. The particle may be anywhere, but it is always vibrating perpendicular to the direction of the wave. So we have two types of wave propagation, longitudinal waves and transverse waves. Now see, the ripples that are produced in water, they are also a form of wave. So you see, here the stone has been dropped, the ripples are produced, and they reach the end of the pond. So these are called as, these are also, by this way, the disturbance created here reaches here. Similarly, the sound also, the disturbance created here reaches in all the direction, goes in all the direction, and finally reaches the ear. So this is how the waves are propagated. Two astronauts on the space mission can see each other in space, but cannot hear each other. This is because sound requires a medium to travel, as vibrations can be transferred from one particle to another only in a medium. Hence, sound waves cannot travel in vacuum. This can be understood by an activity. Sound can travel in all three mediums, solid, liquids, and gases. Sound travels fastest in solids and slowest in gases. The velocity of sound in air at room temperature is 340 meters per second. The speed of sound in air is 340 meters per second. This is the speed of sound in air. Now, you see, astronauts, when they go in space there is no medium. In space there is no medium. So, there is no medium. Astronauts can see each other, but they cannot talk as we do here. So they use wireless phones. They use wireless phones to talk with each other, and they cannot talk directly as we do here, because air is the medium present. So when a person speaks, other can hear. But astronauts in space, astronauts on moon, they cannot talk as we do because there is no medium. Sound cannot travel in vacuum. Sound cannot travel on moon. Sound cannot travel on the place where there is no medium. So for transferring of sound, medium is required. One more thing, sound can travel through solid, sound can travel through liquid, sound can travel through gases. An important experiment to show that sound requires medium for propagation is called bell jar experiment. It's called bell jar experiment. Now, a bell jar experiment is, you take a jar in shape of bell, that's called a bell jar, and this bell jar is of this shape, the shape of a bell jar. Here, this is a jar made of glass, and there's a slit over here, glass slit, which covers it. Grease is applied here so that the air from inside cannot go outside. Now here, there are two tubes are there. One tube is there, and a bell is kept here. This is a bell, a gong of the bell, and an electrical bell. Electrical bell is here, hammer of the bell, and you can take here, this is an electrical bell. this is an electrical bell. These are the wires of electrical bell. The wires are here and they are connected out. Now what happens? This is a bell system. The system is kept here. The two wires are there. These wires are taken out here from here. And this is connected to a vacuum pump. Vacuum pump. Now what happens? Here grease is applied, glass lid is there, and the vacuum pump is here. Now what happens when the current is switched on here? There's a switch. In between them there's a switch. Now when this switch is pressed, the current flows. There's a battery right over here. You can take a battery right over here. Now when the current is switched, the bell, this hammer starts moving in this direction and it strikes the bell, and when it strikes the bell, the sound is produced and you are able to hear. You are able to hear the sound. If you are here, you can hear the sound. The sound will be produced and you will be able to hear the sound. Now what happens? That this is connected to vacuum pump, and the vacuum pump evacuates or removes all the air present inside the bell jar. When all the air has been removed, then again you press the button, so you will not be able to hear the sound, though you will be able to see the hammer moving, but the sound will not be heard. So this experiment is called as bell jar experiment, and this bell jar experiment clearly shows that sound requires medium for propagation. Medium. What is the medium here? That is air. Air is the medium. That is air. Because air, there is no air. So the energy from here cannot be transferred to the next molecule, cannot be transferred to the next molecule. So molecules are not there. So when molecules are not there, energy from here cannot be transferred and it cannot reach you. So sound requires medium for propagation. Sound requires medium for propagation. And this can be proved with the help of bell jar experiment.